there's a lot to say on the fine-tuning argument, and I could probably make multiple videos on it, but I'm going to try to get it all into this one video today by being brief. Just as a way of a disclaimer, the object isn't to teach you apologetics or to convince you that the fine-tuning argument is true. The object is for me to get some practice in speaking and stuff, and I started this YouTube channel so that I can, kind of force myself to do this frequently. So anyway, the fine-tuning argument is, when I first heard about it, I had, all kinds of objections came to mind, and at the time I didn't think it was a very good argument. I suspected maybe there was more to it that I just didn't understand, but it wasn't until I was listening to an interview with Luke Barnes maybe 2 or 3 years ago, and he was addressing a lot of objections to it, that I found it, I started finding it more persuasive, because he responded to a lot of the objections that I had for a long time. Like, for example, one of the objections was that, well, if you just vary, the argument, maybe I should explain the argument first. Okay, so our universe can be described in terms of physical laws, and these laws can be written as mathematical equations. And in these equations are certain constants: the cosmological constant, the gravitational constant. There are other constants like the mass of an electron, the weak force, the electromagnetic force, the strong force. There are all these constants and stuff that just kind of appear in nature. They're not predicted by our theories or anything like that. And so there's no explanation of why they are the way they are. It seems like they could have been otherwise. And it turns out that if you vary these constants by just a tiny little bit, and more with some than with others, then you'll end up with a universe that is not life permitting. In other words, it's impossible for life to develop in that universe. That's basically fine-tuning. And so the argument for God from fine-tuning is that well, if they had to be this, tuned to this really precise to these really precise values in order to allow for the possibility of life, then and there's no physical law that determines them to be that way, so they could have been otherwise. And so it seems like it's unlikely that they would have just happened to be that way, since the probability seems to count against it. Then there must have been some kind of engineer or somebody who intended it to be that way. You can use an analogy with the lottery. Like say there's a 1 in a million chance of winning the lottery, but 3 million people buy tickets. Well, there's a good chance somebody's going to win. But if you only sold one ticket and somebody won, then you'd think the game had been rigged. Somebody did that on purpose. And so in the case of the universe, if this is the only universe that exists, then that seems to be a good argument for a cosmic designer or an engineer of some sort. So one of the popular responses to that is the multiverse. If you've got a whole bunch of universes and each one of them has different constants, as long as you have enough of them, then surely you'll have one that will be life permitting. So there are a lot of objections to this. One of the objections I had was, well, why is life so special? Because no matter what values you have to the constants, the universe is going to come out some way, and there's going to be some unique feature to that universe. Well, that turned out not to be a very good argument, because it isn't just life that we're talking about here. It's anything interesting at all. Like if you take the cosmological constant, if you just vary just by, this is one of the most fine-tuned things. I think I heard an interview with Roger Penrose where he was talking about how, he was kind of uncertain about fine-tuning until he started looking into the cosmological constant. And that's the one that got his attention, he said, because this one has to be, finely tuned to this just unbelievably, small interval or whatever, small range of possibilities before you could get anything. If it's too small in one direction, you get a little pop in the universe, comes back together, nothing ever happens. If you tweak it another way, then you get nothing but hydrogen, nothing ever coalesces into stars, and so you don't get heavier elements, you can't have chemistry. and you need chemistry to have life. So that's basically it. You can think of it as like the universe being fine-tuned for chemistry. And so you've got, like, if you plotted it on a graph, all the possible values that the cosmological constant or other values could have, you get nothing interesting, and also boom, all kinds of chemistry and activities, stars, galaxies, life. You just get all kinds of stuff, and then boom, it goes back to nothing again. So it isn't just life. Okay, so another objection I had was that it seems like whenever people would talk about fine-tuning, it seems like they were imagining that you just tweak one constant in isolation of all the others. And it seems to me like, well, if you tweak them all in proportion, then you could have a wide range of values that they could have and still have life-permitting universes. Well, it turns out I was mistaken about how these things are done. And Luke Barnes, in his book, Fortunate Universe, he and Durant Lewis, his co-author, explained that they actually, when they run these models to figure out what happens if you tweak the constants, they actually vary all the constants at once. And so there's like a range. You can plot them on a coordinate plane. So like say if you were doing 3 of them, you would have an X, Y, and Z coordinate plane. And so you can vary 3 constants at the time. And it creates like a parameter space, a small parameter in which life is possible. So it's kind of hard to graph that if you're using like 26 constants. There's a whole load. I've seen 26, I've seen 19. Now some people cheat a little bit. I've seen some people where they'll take one constant, say the mass of a electron, and some other constant, and then they'll say, both of those individually are fine-tuned, and also the ratio between them is fine-tuned. And so they have 3 fine-tuned constants. Well, there's really just 2 there, because if 2 of those things are fixed, then the third one is going to be determined. It can't be anything else. So some people, like Victor Stenger, think that it's possible, as long as we learn more, that we could find out that there's really very little, if any, fine-tuning at all, because it may be that, if we dig a little bit deeper, we'll find that these constants all reduce down to one constant or something like that. And so there's not as much fine-tuning as there appears to be. Luke Barnes wrote a really detailed critique of Victor Stinger's book, so you can Google that. But it seems like more and more physicists are coming around to this view. I don't remember if I mentioned this or not, but there's a bunch of books on fine-tuning. There's one by Barrow and Tipler called Anthropic Cosmological Principle, I think, and then there's one by Martin Rees called Just 6 Numbers. And so, like, different people give different amounts. Martin Rees, it was 6 numbers. Some people say 19 numbers. Some people say 26 numbers. But supposedly new examples of fine-tuning are coming up all the time. And so there's a lot of research going into all this. Well, let me get to some of these other objections to fine-tuning. Another one is that we're just assuming life as we know it. I mean, if you vary these constants, so the argument goes, then maybe we won't get life as we know it, but maybe we'll get some other kind of exotic life or something like that. But that you would have to really define life very loosely to make an argument like that go through. As long as we're talking about the same thing, life at the bare minimum is chemistry, and so you do need fine-tuning to have chemistry. So I don't think that argument works. That argument is actually in conflict with another argument, which is that some people say, well, if the universe were fine-tuned by a designer, if the universe were fine-tuned for life by a designer, then we should expect that there would be a lot more life. Since that's the purpose of the universe, we should expect the universe to be full of life. But most of the universe is hostile to life. Well, that argument is at odds with the previous argument, because that argument is basically saying that even if you have a fine-tuned universe, most of it's going to be hostile to life, which means that life cannot thrive under just any circumstances. And so if life cannot thrive under any circumstances, then it's not true that you can vary these constants and expect to have life. But as far as this objection about the universe being hostile to life, the fine-tuning argument doesn't depend on there being life at all. All the fine-tuning argument is saying is that you have to have, really fine-tuned constants in order to have life at all, in order for life to be possible. And so it could be, for all we know, that life is a very difficult thing to produce. And so maybe even if you get all the constants just perfect, you still won't get a whole lot of life. But at least you get some life. It's better than no life, So that's not a good argument either. Another argument, this is probably one of the more popular arguments, is the idea that, there's an observer selection effect. Obviously, we have to live in a universe that's conducive to our existence, or else we wouldn't be here to observe it. We wouldn't be asking the question. Well, that doesn't explain why the universe is fine-tuned for life, because we don't have to be here at all. We could have not been here. I suppose you could invoke that if you were assuming that there's a multiverse, because then you could say, well, obviously we couldn't have been in any of the universes in which life was not possible, because we wouldn't be there to observe it. So we have to observe a universe where life is possible. So that would explain why we find ourselves in a life-permitting universe instead of a life-prohibiting universe. But it wouldn't explain why there was a life-permitting universe in the first place. So the puddle analogy you've probably heard about is not really analogous to fine-tuning, and it doesn't really answer the problem of fine-tuning. There's the deeper loss thing. I think I brought this up a while ago, that maybe there's some deeper law that explains all the constants, and if we just understood this more fundamental law, we could derive all our constants from it, in which case they're physically determined. But that is, on the one hand, that's kind of wishful thinking in a way. It's not really that different than the God of the Gaps argument. You're just kind of wishing or hoping that turns out to be the case. But even if it were the case, it would still raise the question, well, why is that law the way it is? Why is that law such that it just happened, the constants it spits out just happen to be the ones that are conducive to life? So that just pushes the problem back a step. It doesn't really solve it. So I guess the final one, the one that has the most merit, I think, is multiverse. If it turns out that there's all these different universes and each one of them has different constants, then it's inevitable that one of them would arise that would be life permitting. So one objection to that is that it's ad hoc, because you're just artificially inflating your probabilistic resources. But anyway, it's kind of ad hoc. Now, some people will say it's not ad hoc because we have certain theories that predict a multiverse, in which case it's not ad hoc. But as far as the models that predict the universe, there's a problem with using that. Some of the models do not result in universes with different constants. Like, for example, in quantum theory, one of the interpretations of quantum mechanics is called the many worlds interpretation. And this is the idea that you've got this Schrodinger equation that's a wave function that describes all the possible paths that an electron can take. And according to some interpretations, eventually when you take a measurement, you make an observation or something like that, the wave function collapses to a certain result and stuff. So the wave function goes away. But in the many worlds interpretation, the wave function does not go away. What happens instead is that the electron actually does take all these different paths, and each one of them is a branching universe. And so everything that possibly could happen does happen. And so if you think about it, when you think about like every moment in the universe, every movement of every subatomic particle and person and everything, every time there's any possible way that things could go different, you've got branching universes. So there's like just an unimaginably large number of them, but every one of them has the exact same constants. So that doesn't solve the problem. And there's also There's the random fluctuation model that I mentioned in a previous video. And this is the idea that you got this enormous sea of high entropy stuff, photons or whatever. And just randomly, there will be a fluctuation of low entropy. Well, in my mind, it doesn't seem like that one really solves the problem either, because even, if you get these random fluctuations of low entropy, you're still going to have the same laws because it's still the same universe. And besides that, it creates the Boltzmann brane problem that I mentioned before. If we're just talking about a random fluctuation of low entropy, well, the lower the entropy, or the more ordered the fluctuation is, the less probable it is. And that means it's going to be a lot more probable that you just ends up with individual brains that have perceptions of an external world and all this kind of stuff, than it is that you're going to end up with a whole universe, because the like ours. And so that prediction kind of just destroys our cognitive awareness of the way the world is and stuff. So that one doesn't work. In string theory, you've got 10 different spatial dimensions and 1 temporal dimension, so 11 dimensions altogether. And we only see 3 of them. The rest of them are like tightly bound up in little knots or whatever. But these tiny strings vibrate, and their vibration determines their properties. But they vibrate in all these different dimensions, even the tightly wound ones. And so the geometry of these other dimensions determines their properties. So they also determine the constants. And so it's estimated that there are as many as 10 to the 500 possible geometries to these different dimensions. And so that means there's 10 to the 500 different configurations that the constants of the universe could have been. And so it seems inevitable that if they all existed, then this universe would exist. Well, string theory doesn't predict that all these universes actually exist. It just allows for their possibility. Really, unless we had some reason to think that there were other universes under string theory really increases the argument for fine-tuning, because if there are all these possible different ways that the universe could be, and yet the universe happens to be life permitting, well, that's the very thing that needs to be explained. There's another one called cosmic inflation, and this is the idea that at the beginning of our universe, in the standard model, the Big Bang theory, there was a short amount of time in which the expansion rate of the universe was just crazy fast and stuff, and the universe just got ginormous in a really short amount of time, like a fraction of a second or something. I don't know how long it was, but some people think that during this time, that's when the constants all became what they are, that the forces used to be unified into one force and they became separated, when inflation was over. Well, if this inflation is something that's happening everywhere all the time, and what we see right now is just this bubble universe in which inflation stopped in this small region of space, then it's possible that the constants in each of these little bubble universes could be different. And so you would get a whole bunch of different universes with different constants, and so you would get one that's life permitting, like ours. Well, this one also creates the Boltzmann brane problem, because if you're just assuming this infinite sea of stuff, you're gonna get some that have different constants, but you're also going to get some that have the same constants, and some are going to be big and some are going to be small. It's kind of random. And so given all that randomness, Boltzmann branes are going to be more probable than huge life-permitting universes like ours. And so that one's problematic as well. So there are other objections to fine-tuning that I didn't write down and I'm not thinking of off the top of my head. If you want to learn more about this, one of the best books I've read, probably the best book I've read, is A Fortunate Universe by Geraint Lewis and Luke Barnes. Luke Barnes is a Christian, Geraint Lewis is an atheist. So the argument is, the book is not designed to convince you that there's a God or anything like that. The vast majority of the book just deals with the science of fine-tuning. and they both are on the same page there. And so they go into detail, more detail than most other books I've read, about the fine tunings of the universe, and about the different constants and parameter space, and how things will be different if you change things. It's really interesting. And this is like, I guess, their specialty. It's something they're doing all their research on. Towards the end of the book, the second to the last chapter, that's where they go into a bunch of objections to fine-tuning, the common objections they get when they go out and speak, to other cosmologists or whatever. They bring up the most common objections they hear. The last chapter in the book is where they talk about the implications of fine-tuning. And Durant Lewis subscribes to the multiverse, and Luke Barnes subscribes to the designer explanation. And they have kind of a dialogue where they go back and forth and they question each other and stuff like that. So it's really interesting, and I recommend that book. And Luke Barnes also there's a lot of videos on YouTube featuring Luke Barnes where he talks about fine-tuning and he answers objections, and I think he may even debate in some places. I don't know. But Luke Barnes is really the one that kind of turned this whole thing around for me and started making me think this argument is more persuasive than I originally thought it was. So I'm still kind of new to it. As far as whether I personally find it persuasive, if it were the only argument I had to go on for the existence of God, I probably would not find it that persuasive. I don't know. I really don't know. I might. I would be very interested in it. But I don't know if it would be sufficient to make me believe in God by itself. But in combination with the other ones, it does seem pretty persuasive, because it kind of coheres with the previous two cosmological arguments, the argument from contingency and the Kalam cosmological argument. Because now, before you had something that was made by some immaterial being, and now you've got an engineer to the universe. Well, it makes sense that if there were an engineer to the universe, that would suggest that the universe was made. But nothing about the fine-tuning argument, shows that the universe was made, but just that it was designed. And so how do you get from the design to the making of the universe? Well, the cosmological arguments answer that question. And so they kind of complement each other in a way. And also, if the fine-tuning argument for God is sound, then that would give you a personal somebody behind the universe. You can't tell just from the fine-tuning argument and the cosmological arguments that the designer of the universe was the same person as the maker of the universe. Maybe they tag teamed it or something like that. But I mean, if you wanted to use Occam's razor or something like that, you could say, the designer and the maker are probably the same being. But I don't think you can say that with any kind of certainty, without other arguments to add on to it. And I guess that's about all I want to say. I'm almost certain that as I drive home today, I'm going to think of other things that I wanted to say. Like I said at the beginning, I'm doing all of these off the top of my head because I'm trying to learn how to speak without notes and speak without a teleprompter and just get through sentences and words and be able to think clearly while I'm speaking. I can think perfectly clearly while I'm not speaking. I can even think clearly when I'm writing. But for some reason, speaking just turns my brain off, and it's just so difficult. And I go back and listen to myself and how many times I misspeak and all that I say the wrong word without even noticing that I have done it. Man, if I were running for president, there would be so many videos about my gaffes. I would be worse than Joe Biden or George Bush. But anywho, there we have it. Thanks for coming. I guess the next argument I'm going to tackle is the moral argument. So there you have it.